Why do boats float but rocks sink? Ahoy there! Have you ever thrown a rock into water and watched it immediately sink to the bottom? Or seen a massive boat gently bobbing on the surface of a river or a lake? Today, we're going to set sail on a wonderful journey to discover the science behind why boats float while rocks sink. Let's start with something called buoyancy. Buoyancy is a magical force that helps things float. Imagine this. Every time you put something in water, that object has to push aside some water to make room for itself. The amount of water it pushes apart is important for understanding whether it will float or sink. Now, here's the fun part. If the object pushes away more water weight than it weighs, it floats. If not, it sinks. So what does this mean for a rock? A rock is small and dense, which means it doesn't push away much water before its own weight starts to send it downward. But how about those gigantic ships? They're very big and full of air and not as dense as you might think. They are shaped to push away a huge amount of water, much more than they weigh. Imagine a giant, light bathtub. Boats are built with big hulls filled with air. This design helps to spread their weight over a big area, pushing lots of water out of the way and making them buoyant. Think of it this way. Imagine a large balloon. If you try to press it into the water, you notice how much resistance there is because it wants to pop back up. That's similar to how a boat acts, but it's not just air. It utilizes smart design to play with buoyancy. Boats also rely on something called density. Density is like a measure of how tightly packed stuff is inside an object. Comparatively, rocks have particles tightly crammed in a very small space, making them very dense. But boats are big and have a lot of air inside, so they're less dense. When you're less dense than water, up you float. There's a principle called Archimedes' principle, named after a Greek scientist, and it explains all this beautifully. It says that the force making something float is equal to the weight of the water it pushes away. That's why when you dive into a pool, you make such a big splash. The water has to move to make space for you. So next time you're near water, you can think about all the wonder underneath. A tiny pebble will sink like an anchor, but a splendidly designed big boat sails across with elegance. All because of the hidden magic of buoyancy and density. Now that you know the secret, maybe you'll